So I'm going to go through example number 5 in your textbook, which is actually on page 653. This is the Sullivan and Sullivan textbook. So they go through and they give us an initial formula here where my input's an angle. V naught is some initial velocity. And then I've got two trig functions going on. And they want me to show that this is actually, I can reduce this from two trig functions, a product, to just the sine. So when I look here, if I wanted that to be the double angle, I'd need a 2 in front of that for sine theta, cosine theta. And since it's an equation, I just can't put in a 2 without compensating. And so if I take a half and times it by 2, I still have 1. This gives me that double angle, and then I can multiply these together. So I end up with 132 V naught squared, and then that's equal to twice. Actually, not twice. The sine of twice the angle. So we've shown now that it's equal to 132 V naught squared sine of 2 theta. Now they want me to find a maximum. So if you remember the sine wave, it has a maximum when the sine is equal to one. That's the highest a sine wave can get, regardless of what this information is. So that means that twice my angle would have to be at a 90 degree. So my angle would be at a 45 degree angle. So when your input is a 45 degree angle, that's how you'll get your maximum range. So this is textbook example number 6, and we're just going to go through, and I'm going to do B since A is already there. So they want me to find the exact value of sine of negative 15 degrees. Well, I'm going to pull the negative out in front because sine is an odd function. And then when I think about 15 degrees is in quadrant 1. So it's going to be plus the square root of 1/2 1 minus cosine at 30 degrees using the half angle formula. So I'm going to now have negative 1/2 1 minus cosine at 30 degrees is the square root of 3 over 2. So I now have negative 1/2 minus the square root of 3 over 4. So that's 2/4 minus square root of 3 over 4. So I come up with this equation right here for the sine of negative 15 degrees. Now if you'll notice down here, you didn't have to use the half angle formula. You could have actually used the difference like with the cosine. So let me show you that. I could have said, well, wait a second. 15 degrees is the same thing as sine at 45 degrees minus 30 degrees. And then you could have had negative sine 45 degrees cosine 30 degrees minus cosine 45 degrees sine 30 degrees. And that would have been another way to solve this problem.